Hello everyone, my name is Venkata Sai. I'm student of IT Kharagpur. I am in a DIY group project in which we make this Ornithopter, which is an aircraft which looks like a bird. And here we can observe these are the wings. This is the shaft on which we wind the rubber band, and this rubber band will rotate the shaft such that these two wooden sticks will move these two wings flap. And we can observe this tail. Here, this tail is slightly bigger than what I presented here, and the angle between these two sides is 45 degrees. This is proved that if the angle is 45 degrees, it can fly in a better way. And you can observe that this tail is out of the plane of this body. This helps that this helps this ornithopter to fly in this way, and this thrust force will help to fly above and get stability. And this is the body of this which will hold this shaft and this rubber band and has more tension in this. So we choose this to be strong and less weight so that this ornithopter will fly in a better way. Thank you.
लिखा हुआ दिखा। हम्म। हाँ।
अरे
अरे वाह.
Hi friends, my name is Anand and today I am going to show you the working principle of my ornithopter. So we can see that this is my ornithopter. So let's begin. There are four important parts in an ornithopter: the wings, the tail, the fuselage and the crank. So let me begin backwards. The most important part of our ornithopter that facilitates its movement is the crank. So here we are using a very simple and very interesting double crank mechanism. It is a very famous mechanism used in many other devices. So what a double crank does is that it has two different radii, two different arms on which these two connecting rods are joined. So we can see that they are mounted on two different arms from this view. See. So it is quite obvious what we will do. We will apply a rubber band on this end of the hook and the other end on this end of the hook. So when we wind the rubber band, the potential energy in the rubber end will be generated and it will tend to unwind. So when we let it go, it is going to unwind and along with it the wings are going to flap like this. This is happening because the wing spars are pivoted in these two small tubes. So when we rotate the crank in this way, the wings are going to flap in unison up and down. And why it is happening? Because we have chosen a very specific angle and dimensions for the crank. So let's move on to the next part. The next part is the fuselage. Now this is a very important part because it needs to be lightweight and also strong at the same time because it is supporting the entire tension of the rubber band. Also we have this stick here which is supporting the wings. So this is a very important part. This is the main body which is the reason for most of the weight of our ornithopter. So what we will do here is that I have used balsa wood here. Its density is around 120 to 130 kilograms per meter cube, which is less than 1/4, around 1/5 of the teak wood that we use in our furniture and stuff. So, but also at the same time, it is also quite strong when it comes to tensile strength when we use 2 or 3 sticks together. So that is all about the fuselage. The next most important part is the wings. Now the wings are the main reason our ornithopter is flying. So the wings are the main reason our ornithopter is flying. The lift force is being applied here. So when we rotate our wings at a very fast rate, the lift force that is applied, it will lift the ornithopter above the ground. Now 2 or 3 more important things is that the wing span must not be too large or too small. It should be perfectly balanced according to the size of the ornithopter. Also, if we make it too large, then what is going to happen? This wing is going to become slack, which will not allow it to fly. Now if it becomes too small, then the force is simply not going to be sufficient to lift the ornithopter. Now also the stick that is connecting the wing here, it should be perfectly parallel to our fuselage. Otherwise, if it is tilted in this direction, then it will fly in this direction, and if it is tilted in this direction, it will fly in this direction. But if it is perfectly straight, then it will fly perfectly straight. So we need to set it according to where we want to fly. Now coming to the last, the part is the tail of our ornithopter. Now the tail of the ornithopter might seem like a vestigial part that is not so important, but it is actually a very important part. Without this, our ornithopter is simply not going to take off. So why is that? So first of all, the tail is the part that helps us in balancing the ornithopter. For example, if our ornithopter tilts upwards, then the tail angle can be increased so that the lift force here brings it back. And if our ornithopter tilts downwards, then the tail angle needs to be decreased so that the lift force in this side decreases and it comes back to its original position. Now this model that we have made is actually a very simple mechanical model. If we can also make further advanced RC models and stuff like that, in which we can control the angle of the wings and the angle of the tails in between the flight. However, we cannot do it here. We should set it beforehand according to the kind of flight that we want. So that's all about my ornithopter. Thank you.
Hello everyone, I am Atishay Jain and this is the Ornithopter that I have made. Now I would like to tell you some of the problems that I faced while making it. So while making this, the front cranks and these 2 sticks, I have to be very precise with the measurements. So 2-3 times I failed while in moving it smoothly, because if they are not of equal length and if the angles that in this are not precise, then the rolling will not be smooth and the efficiency will be reduced. Also, we have to be precise with this tail angle also, and this angle that with this the tail makes, it should also be carefully noted. However, we can't predict it because it depends on the wind conditions, and we have to find it experimentally by flying the ornithopter 2-3 times. Also, the problem that I faced is with the wings. Like when the ornithopter fall on the ground, then the wings got damaged and I have to replace it. Also, the main problem is that we have to find the rubber band which will work for it, because there are many rubber bands that I have used. Like from this one, I have found two and then used them in pair to put it here, because if we use wrong rubber band, then it may break. And many other times this front crank, this front cylinder, it moves back because the rubber band was applying a very high amount of tension. And also, while making it, when I make these sticks from the big board of the wood, I have to file them, because while cutting them I take a margin for the error, but then when I measured it, it resulted in a high weight, so I filed it and then reduced the weight.
Now I'll be explaining the APD involved in this ornithopter. As we know that major forces will be acted on the wings itself, because wings are the most criterion part, and it is the most important part involved in this ornithopter. And remaining all parts like the base stick, etc., and etc., are just a mass creating stops, and which are not responsible for the flight. It is just for the support. Okay, and I won't be explaining every part involved in this, and I'll go to some special definitions of the forces whichever are involved in this. For example, let's go to induced drag. It is that part of the drag which arises from the development of the lift. And airfoil drag. The thicker boundary layer also causes a large increase in the pressure drag, so that overall drag increases sharply near the and past the stall point. See here, what happens is lot of air density goes below above the wing, so that pressure behind the wing increases. So it creates a net upthrust above the wing, which is also known as Bernoulli's theorem. Like it is not known, it is calculated from the Bernoulli's theorem. And let's go to the attack angle of attack. It's nothing but the angle at which the chord of an aircraft's wing meets the relative wind. The chord is a straight line from the leading edge to the trailing edge. And now let's go to the, and as per my search, and as per whatever theory I have read, the best angle of attack is 15 to 20 degrees. Induced angle of attack, the downward vertical angle between the horizontal and the velocity related to the wing of an aircraft of the airstream passing over the wing. Okay,